Alright, well this is a 6NZ buildup right here. As you can see, to recap what we already done, the engine's tore down, and the engine that we're going to be building is a 6NZ, and we're going to build it for high horsepower. We're going to put a set of Acert twin or compound turbos. Compounds. Don't want anybody to be correcting me here. I know that it's a compound turbo setup, not a twin turbo setup. Anyway, we're going to go for a lot of power here, but yet we're doing everything with an eye towards reliability and make a long-lasting engine. So we tore it down to bare block, sent the block and crank out to the machine shop, had the block decked and the crank polished. And while it was gone, I cleaned up all the gasket surfaces on all the various parts that were don't be reused. And then the piston packs, we're using IPD single piece steel pistons to get away from the factory aluminum skirted pistons, which are less tolerable to heat. So the IPD single piece packs, you got to reuse your OEM rod, and so I had to assemble all those. Now here we got the block back from the machine shop, and the number 6 hole had been counterbored and shimmed before we tore into it. And so when you deck a block, you bring your liner height to like 3 or 3.5 thousandths protrusion. That's just the way it assembles with a totally flat block, stock spacer plate between the block and the head. So theoretically, the other 5 that weren't counterbored before should be right there at 3.5, which is great because we're going to O-ring the head, and that's the liner protrusion you want to hit is right around 3.5 or so. But that number 6 being counterbored, we gotta deal with that because they didn't deck so much off the block that it got rid of that counterbore. Our smallest shim is like, what is it, 31 thousandths? I forget exactly. I think it's 31 thousandths. So we got to cut that counterbore down to the thickness of that smallest shim, and then when we put the shim in there, it'll raise the liner up so it'll be perfectly in line, same height as the rest of them. So that's what I'm doing here. I'm measuring the block deck down to the cut surface area there, and I'm being as precise as I can. I want this to perfectly match. And eventually I did get there, but you could tell it took a while. Next thing on the block before starting to put things back together is I had to address these bores for the pistons. Down at the bottom where the liners seal, where the water jacket seals, there's pitting there, and so you can see it's pretty rough. It's actually creates sharp edges there. Typically they're on the exhaust side. There's more heat there anywhere else than on the exhaust on the thrust side. So I want to smooth that out in order to keep from cutting O-rings. So I used some quickset JB weld and spread over the area and then sanded it down. And that will get the O-ring past the pitted area into good land for that O-ring to seal against and leave the O-ring, undamaged. So with that all done, flipped the block over, and now I'm putting my main bearings in. You want to make sure that the back side of the bearing's totally dry, that the block's totally dry. So we get it seated in there and then put some assembly lube on it. Drop the crankshaft in. Now again, when you're putting the crankshaft in, you need to hold it by the first and last main rod journals, and that clocks the crankshaft so it'll go into the block. If you get a hold of any of the other journals, it's going to set where the crank's too wide to go down past the sidewalls of the block. Gently lower it in there, take my straps off, and then we got to put our main caps on. well, thrust bearings first, I suppose. So those, I got the wear side that goes against the crank lubed, and the other side's dry. And so there's gaps there on the number 4 main journal where those thrust bearings slide in. Now here we got our main caps. They're marked, they're numbered 1 to 7, and each one says front so that you know the direction and don't mess them up. So set them down in there, and then I like to take a hammer and get them seated pretty well. Run all the bolts down. Before installing all those bolts, I did lube them, both the threads and both sides of the washer, so that our torque is completely predictable and smooth and uniform. And this uses a torque turn method where you torque each bolt first, and I forget what it is, 190 pounds or something. And then after that, you put marks on the bolt head and turn it 2 flats. That'd be 120 degrees, yeah. So we'd use the 3/4 inch impact to turn it, and really it makes the job pretty easy, especially when the block's upside down. Crank's in place, so we can flip it back over. I found this is the easiest way to flip a block over, is these hanger brackets from OTC. You can bolt them anywhere on the block with 7/16 or smaller bolt, and they work great on straps like this or chains or whatever. I think each one of those brackets will hold 2 tons of weight, maybe 1 or 2 ton. I don't know. They're way overkill for this. There's no worry. The straps hold 1,000 pounds a piece. I think the hangers maybe hold 2,000 pounds a piece. So anyways, we got plenty of strength there to deal with all that weight. I've seen guys flip blocks other ways, but I don't think I've ever seen one that is as quick and less dangerous, you know, less power. You got to put less work into it. Letting the forklift do it is pretty nice. So they're lubing the bottom liner O-rings with basically water and soap, and then the top you soak in oil, and that top rubber band that goes at the top of the liner, you got to lube it, get it on the liner, and then get it pushed into the block pretty quick, because it's going to start swelling, and it has to swell and seal against the block there. You can see I got a little homemade press there that uses a head bolt to anchor in to the block, and then just a bar, and push the liner in. Here I did have one broken off bolt in the block, and so drilling it out real quick, just used an automatic center punch to mark the center of the bolt, and an 1/8 inch cobalt drill bit to drill it out. And nice thing about broken off bolts inside engine blocks is they usually come out super easy. I just grabbed my pocket knife and stuck it in the end of the hole, and it came right out for me. No big deal. These 6NZs, they started upgrading the bell housing back there. I don't know if they did it on the 2WS or not. Could have. But anyway, instead of having a paper gasket there at the back, or a full gasket, they went to these rubber seals, and they seem to work pretty good. We don't tend to have tons of rear bell housing leaks like me used to have. So getting it mounted up there, there's a torque pattern, 2 different size bolts. Obviously I'm not showing all this because I want you guys to watch the whole video. Once the bell housing's secured to the block, then we put the rear main seal in. I love putting cat main seals in. because the tooling for them just works pretty flawlessly. As long as you assemble it and tighten it absolutely all the way, you can't really screw it up, unless you put a front seal in the back of the engine and a back seal in the front of the engine. The seals are designed with a spiral in the rubber, and it spirals the oil away from the seal according to crankshaft rotation. So if you put a front seal in the rear, instead of spiraling the oil away from the seal and back to the inside of the engine, it'll start pumping oil out of the seal. You'll know right away you screwed that up. But the seals are marked with crankshaft rotation on it, so that you know what should be front and back. You just got to know what crankshaft rotation is. On engines, they don't tell you front and back on engine rotation, because if you had the engine in an application where it's sitting backwards, like in a school bus, they used to run them backwards, stuff like that, people would get confused and put them in backwards and blame the manufacturer. So here there's a bunch of studs that go in this gear cover support, or whatever you call that, and most of them have seals on those studs to keep the oil in the case. There's, I think, 3 or 4 studs that are on the inside that they're completely internal and bathed in oil, so you don't need seals on those. So that's what I was doing right there, is picking out the ones that were from the inside. I wanted to find the ones that didn't have paint on them. I hate seeing painted hardware inside of an engine. You should be paying enough attention putting an engine together that you put bolts back where they came from. And painted bolts, painted washers should be on the outside of the engine. It should be pretty clear to people. So there I am. You get the seals on there, get the knurl lined up with the steel, and pound them on in place. Before putting the gear case backing plate on, there's 2 half-inch studs that it's part of what holds the fan hub on. So screwing those in, I put pipe dope on the threads, some really good stuff, and tighten them in. And then we put our gasket on, and then go back with some gaskets. Or, well, no, never mind. I put gasket and seal it on after this, I guess. But you got to watch those studs. If you don't seal them really well, it'll wick oil through the gear case and down onto your fan hub. Your fan hub's going to spin the oil all over the front of the engine, and then people think that the front main seal is leaking, whereas it's just those 2 studs didn't get sealed properly. There's not a ton of bolts that hold that backing plate on, just a few. They're all internal to the gear case, so just gotta, again, recall which are which, because like the stub that I'm putting on for that idler gear right now, it also goes through that backing plate into the block, but you know, you got to know, there's some bolts that don't hold hardware on like that. Some do. So you just got to keep things kind of organized. Think about what you're doing. There's 2 idler stubs there, and you got to remember underneath each of those, there's 1 bolt that holds the backing plate on. So if you put the stub on too soon and forget to put that bolt behind it, you'll end up with extra bolts. There's our bowl gear. It does have a timing mark on it. You put your crank top dead center on number 1, and then that bowl gear lines up with the timing mark on the crank. Little idler there. Just lubing all the bushing surfaces there with some assembly lube. Now that there's the adjustable idler. So while I'm assembling it, I'm leaving all the bolts loose. Put some Loctite on all these bolts. I use blue Loctite on everything. But yeah, that adjustable idler, we'll get to it later and get in position later. Now on these paper gaskets, anytime we use those, for the most part, we use some red high-tack spray gasket, like I don't even know what you call it, gasket spray anyways. And it's tacky. You let it set, you spray it on the hard part and on the gasket and let it set for about 5 minutes. And then you install the gasket, and it'll be tacky enough to hold the gasket in place. Plus it seals the gasket really good against the metal parts. I've seen a lot of people use silicone or gasket maker on paper gaskets, and some people can get that to work. I cannot. I'll end up with leaks. That high-tack seems to work way better. There I'm putting that gasket sealant around the studs in order to keep oil from wicking up out of the gear case there around those studs. You can see I got the gear cover next to me there, and I've already sprayed it with high-tack, so it's already go on. The two studs line you up pretty good, and then there's 2 dowels at the bottom. And then again, you just got to know which bolts to install. It's not a ton of them on the front. There's a couple big bolts, and then like 1/2 inch. Then there's 6 1/2 inch bolts for the front engine mount. And then, I don't know, there's probably 7 bolts maybe that you can install at this point. The bolts for the water pump screw into the water pump, so there's not really any bolts on that end. So a lot of times I'll run the bolts, or I'll put the bolts in with nuts on the backside so I can clamp the gasket between the backing plate and the gear cover, and let that high-tack set up between those two pieces. Now there's a number of bolts on the back side of the gear housing holding the backing plate to it. So installing all of those that I can. There's the accessory drive right there. It drives the power steering pump and the fuel pump in most applications. And there's roller bearings in it. And I don't think a lot of people think about it, but I have seen more than once, I've seen those bearings go out. So while we're here, the bearings are $20, $25 a piece. We're going to go ahead and replace them. I love this arbor press here. It's very quick to use to push out and push in bearings that aren't like a super tight fit. Just a cool piece of old equipment. Using a bearing splitter to get the bearing off the shaft there. I don't know how old that arbor press is, but it's a pretty cool piece of equipment. I love being able to incorporate and use old equipment like that. The design and everything's just super cool. And you know, as old as it was, I didn't pay nothing for it. Just modern shops don't tend to use old equipment like that. Like, you know, I mean, there's plenty of repair shops that do, but I bought that from a machine shop, and I doubt you see a whole lot of machine shops with old equipment like that anymore. Bolting the piece into the housing, and there's a snap ring there, got to put it in, and we got new bearings. Again, all of these bolts have blue Loctite on them. I like to make sure that everything is going to stay tight and not back off and leak eventually. Probably imagine you can hear I'm doing this in the morning after a vacation. I'm not going back to work yet, and my kids just woke up. So if it sounds like there's a herd of elephants above us, the kids are up. Now that high-tack, it's awesome stuff for holding gaskets in place and sealing gaskets, but what I was doing there is when you get overspray, the yellow paint will not cover it. I know Cat makes a primer, maybe that would cover it, but it won't cover the red, so you gotta spray it down and wash it off. So that's part one of the build-up. Basically out there is a standard build for the most part, other than the IPD single piece pistons and setting the liner protrusion to 3/1000ths of an inch. It's what I do for pretty much any build that I'm doing, on an outer frame anyway. On an in frame, obviously, we're not resealing every single surface on the engine and replacing every single gasket. But since this is out of frame, we're taking advantage of that, and we're going to make the best engine we can. But come next video, we're going to get into all the special parts we're putting in. The fuel pump, the cam, the head, the turbos, the tune, and a few other pieces. So anyway, I've had guys wanting to see how an engine goes together, and I thought, you know, this would be a good chance for people to see how these cats are assembled and put together. If you appreciate these videos, if you like them, don't forget to subscribe, like the video. It helps me out and encourages me to keep doing them. Thanks.